Greetings, my fellow humanoid dwellers. I create videos on technology and other random things. If you like this video, you might like others. If you don't like this video, you still might like others. Consider subscribing to my channel or checking out my Patreon page. If you already subscribe, hit that bell. In this tutorial, we're going to talk about Ohm's law. I'm going to replay the video from the previous tutorial. Only in this one, I'm going to have some graphics that will show how we compute the values that in the last video I just said don't worry about. For the most part, you're not going to use Ohm's law very much. You're just going to grab a resistor, you're going to put it in, and it's going to be close enough. But it's good to go over things so you have a better understanding of how some of this stuff works. We're going to start by looking at current. In Ohm's law, the way you find current is voltage divided by resistance, or I equals V, voltage divided by R. The reason they use I for current is because some French scientists back in the olden days always referred to current as intensity, and so they decided to name it after him. In our circuit, we have two 1K ohm resistors in series. When resistors are in series, you add them together. So the total resistance for this circuit is 2,000 ohms, or 2K. So 30 volts divided by 2,000 will give you 0.015, or 15 milliamps. So now when we go to turn on the circuit, we should get 15 milliamps. If you remember, there's 15 volts across each individual resistor. If you adjust that and make 1,000 ohms, or 15 volts divided by 1,000 ohms, you end up with 15 milliamps. The same thing you get if you divide 30 volts by 2,000 ohms, and that's why the voltage divides up evenly between the two resistors. Now we swap out the 1,000 ohm resistor with the 10,000 ohm resistor, and now we're going to calculate it up the other way. In this case, it's resistance equals voltage divided by current. Our voltage is 30 volts. Our current is 2.73 milliamps, or 0.00273 amps. So 30 divided by that gives us 10,989 point something, which is pretty close to 11,000 or 11K ohm resistor. For our final example, we're going to compute the voltage that's applied to the circuit. If you remember from our last tutorial, we bypassed the 10K ohm resistor, or the 10,000 ohm resistor, by switching the meter to read current. So we had 2 meters reading current and 1 meter reading voltage, which essentially made the circuit a 1,000 ohm resistor. Once we turn the circuit on, you'll notice that it's reading 30 milliamps. If you take 30 milliamps, or 0.03 amps, and multiply it times 1,000 ohm resistor, or 1K ohm resistor, you get 30 volts, which is the voltage that's applied to this circuit. The main calculation you want to get from this tutorial is how to compute current, which is voltage divided by resistance. In the next tutorial, we'll incorporate an LED, and it will further emphasize why you need to know how to calculate current. Thanks for watching.